Before I go any further on the animation tree, I was thinking maybe in the examples that we did before with the blend space 1D or even simple movement, maybe we could have added a joystick in which we could translate the movement of the joystick into a movement vector and then use that instead of the arrows on the keyboard. Of course, we could have gone into Assetlib in the middle top and the middle right of our editor and type in joystick or virtual joystick. And we'll get some great plugins. I've tried this one by Saulo de Souza and this one by Marco Fazio, and they seem to be really good. And when you add in plugins like this, most times you have to go into project settings and plugins, and at the top here you'd see the plugin name and a checkbox asking if they enable, and you have to enable that, and then you can use it according to their documentation. And it's pretty simple, it's nice and easy. But then it got me thinking, why don't we just design our own simple joystick? Because these joysticks are really good and they have a lot of features, but sometimes the features might be a little confusing for a beginner. But the joystick I'm thinking about making, I'm just going to make it really simple. So let's do that in this tutorial. And of course, if we know how to make our own joysticks, we can actually understand other people's plugins a little better. Okay, so let's clear this out. And I want to start with a control scene. So we're going to use the user interface, this control scene here. And there's a reason I want this control scene. Let's switch across to the 2D scene here. There's a reason I want a control scene. It's because we're going to use something called GUI input, which gets the input on control nodes automatically. It's a built-in function, and that makes life so much easier. So let's rename this virtual joystick, and we can probably save this for now. And I created my own assets for the joystick ring and the joystick knob, so I'm just going to import them. I created them on Inkscape in case you want to try them on your own, but I'll try to upload it somewhere so that you can download them, and I'll include a link in the description somewhere. So let's just create a folder and just call it image files or something like that, and we're going to drag this in to our image files folder, and there we go. So as you can see, you can just put them into the project and see what it looks like. So we're going to use these two files. This will be the ring around the joystick, the background ring, and this will be our actual joystick. We're going to use those to create our own virtual joystick. Let's delete these two things, the knob and the ring, remove them, and instead of using them directly as sprite 2Ds, we're going to use them in a TextureRect. And the reason we're using TextureRects is because we want all these nodes to be control nodes, so they can work in tandem with each other. So let's click the plus here and search TextureRect, and there it is. And let's name this background ring or something like that, and let's just copy that, Control D, and we'll rename this stick or something, and that's perfect for now. We can, in the background ring, we can drag the ring, and the knob we can drag the interstick. If you notice on the right hand side on the inspector, you can add it here as well, but they already added when we dragged it into the nodes. Now we just want to position these in a nice way so that they will look like an actual joystick. Okay, so let's select our virtual joystick, the main node, and you notice this orange border around here. That's the size of the view rect. I don't want this border to be this big, just want it to surround the circle alone. I'm going to layout, and make our minimum, custom minimum to the minimum of the circle. My circle, I made it 200 pixels by 200 pixels, so let's use that. If you have a circle that's different proportions, you may want to use those. And the transform here, we want to change that 200 by 200. And if we click it again, we'll see the borders are right around the ring that we wanted. Let's save this. The virtual joystick, I want its anchor preset to go to the bottom right hand corner, because that's where most right-handed people use their virtual joysticks on a touchscreen. Let's select our background ring, and for the background ring, let's leave the anchor to top left, because calculations for control items are usually done from the top left corner. But in the inspector, we'll leave the expand mode to keep size, but the stretch mode will change it to keep aspect centered. Let's select the stick. Let's leave the expand mode to keep size as well, but the stretch mode will leave us keep aspect centered, but we're going to change the anchor preset to center, so it's in the center of our background circle, and this is beginning to look like a joystick. Let's save this. We can just run it for now and see how it looks, and that looks great. And if you believe the stick part looks a little small, we can always raise its size by changing the minimum size to 100 maybe, because I made it at 50 by 50, which probably looks a little small. And let's see how that looks, and that actually looks much better. So let's save this, and let's click the root node and add a script. And let's just create that. Let's remove all these extras here and save this. I just want to get a reference to the background ring and the stick, so let's do onReady so that it will be loaded when the scene is fully loaded. Then it stores these nodes. So at onReady, let's say var, and let's call it BG circle or BG ring, whatever you want, is equal to, and let's drag across the reference to the BG ring, and let's do the same to the onReady again, var, and let's call this one stick, and this will be equal to the stick. Let's drag across the stick. I want to create two variables here. The first variable will be the circle radius, which will be the background ring that we have there. So let's say var bg circle radius, whatever name you like, and that will be a float. We have to calculate this later on. And let's create a boolean, pressing dragon. Let's call it dragon. It could be, might as well be pressing, it doesn't matter once you know what your code is doing. Automatically set it to false, and let's save this. Okay, and let's create our onReady function, our ready function. And we're going to calculate the circle radius, the background circle radius in here. So let's say bg circle radius. And remember, our image that I created was 200 by 200, so it's perfectly square. So we just want to calculate the radius by using the size of the circle, but it's just one side we need, either the x or the y, and we want to get half of that because either x or y will be the width or the height of the TextureRect. So we multiply by 0.5 to get the radius. And here's where we're going to use this new function that I mentioned, the GUI input. It's quite similar to the underscore GUI. Great. It's quite similar to the normal input that we used before, but this one is specific to control nodes, which is why we initially use control nodes, the green nodes, to create this virtual joystick, so that we don't need any more sort of nodes to control input. like buttons or things like that. It will automatically be detected using the GUI input function. And the code is similar to the other codes. If the event is, and let's just type in touch, so it's an input event screen touch, or if that event is a screen drag, so let's just type in drag, and there it is at the top. Firstly, we want to get the position of that touch, so let's create a variable and let's call it maybe touch position or touch pause will be equal to that event position, just like the other codes that we used to. Let's save this for now and let's set dragging to true. And for now we can just print our touch position. Let's just see if it works. Let's save this and run it. Let's move this up a bit, and nothing is happening. That's because, of course, we are writing code for touch screen and we're using mouse. So we have to go into project like we did before, go down to pointing and click emulate touch from mouse, and we could probably turn off the mouse from touch because we're not using a touch screen device to do programming. And let's save that now and let's try this again. So if I touch the screen, you can see anytime I touch inside of the circle, it's registering something. So we actually get in local coordinates when I touch inside the circle, which is good because that's why we created the orange border right around the circle alone. Let's close this. Okay, we know our touch position is working, so let's remove the print statement. And we'll want to update the position of the stick at the center anytime we touch the screen. So let's create a function, let's call it update stick maybe. That's a good enough name. And we'll want to pass in the position that we're touching, which is our touch pause. My beautiful spelling. And of course we're going to get an error because update stick does not exist. So let's go below that and let's create our update stick function. And let's just set pass for now. And of course we're getting the error because we didn't set the parameter in our function. So let's just give it an easy name like pause for position. And of course this will be a vector too, because positions in 2D are vector 2s. And the error is gone. Let's save this. Let's fix our function now, our update function. First of all, we want to find the center of our circle. So let's create a variable called center. And we want to get a position of our circle, because we can move the circle anywhere within the screen as we like. So let's just get our position. And with that position, we want to get the center of the circle. So we reference the BG circle again, and size multiplied by half. And this is going to give us the center of our circle at whatever position it's in. We want to get an offset from this because we're going to place the stick in that offset. So let's just say we'll call it offset is equal to the position in the parameter minus the center that we just calculated. And now we just want to use all that information to more or less clamp the stick within the boundaries of the circle. So let's just say if the offset length is bigger than the radius of the circle, we're going to reset the offset to the largest radius. So let's just get back our offset and let's normalize that so it doesn't go beyond 1. We spoke about normalized in another video already. And multiply that by the background radius. So if the offset is 1, it's going to give us the actual radius. 1 multiplied by the radius will give us the full radius of the circle. If it's any proportion of that, it's going to give us that proportion relative to the radius of the circle. And now we just want to set, this is an update stick function, so we want to set the position of the stick. So let's type stick dot position is equal to center, because our stick is moving around a center position. Let's add our offset, be it positive or negative or whatever it is, and minus the size of the stick. Well, half the size of the stick in this case. So the stick size multiplied by 0.5, because we want to center it. Let's save this and we can test this out and see if it's working, because we already have the update stick function in our GI input here. So let's see what happens if we run this. So now, yes, it works. As you can see, the stick is going right around in a circle but not moving beyond that, and that's exactly the behavior we want. Let's release, but it stays right there. So now we have to add code for it to jump back to the center when we release. Let's close this. Let's just write a small little function to reset the position of the stick. So let's call it reset stick, and it's going to be a simple function. Let's just type in stick dot position. It will be equal to the position of the circle dot position plus the half the size of the circle multiply by 0.5, and we're going to minus the size of the stick by half, because we wanted the center of the stick to line up with the center of the circle. That's basically what this is doing. Let me just widen this because I can't see my code. Stick that size multiply by 0.5, and let's save this. But this function is not being called anywhere, so we need to call it when we release the touchscreen. So let's go below this if statement in the GUI input, and let's create another if the event is a touchscreen event, like we already did here, and that event is released. We want to call reset stick, and don't forget to reset dragging defaults. Let's just save this and see how it works. I'm going to drag it around, and when we release now, it snaps back to the center. That's perfect. And I'm just realizing that I never really used the drag-in variable. I had intended to use it in one of these functions here, but it's not necessary. It was never used. So let's just delete the drag-in variable, and the code is supposed to work exactly as it did before. So we have a moving joystick now. All we have to do is be able to access the vector that is creating inside of the joystick itself, so that we can use it externally. Because what's the point of having a joystick without being able to use it to move something on the screen? So let's go down to the bottom. So let's create a function called getVector or getJoystickVector or something like that, so that we can easily recognize the function name when we are calling it later on. Vector, and of course we will want this to return a vector 2 that we can use somewhere else, and we want to calculate the center and the offset again. So what I'm going to do is I'm going to move center and offset definitions to the top. So let's say var Center is a vector 2, and var offset is also a vector 2. And let's remove the var declaration here and the var declaration here. Let's just return a fictitious vector for now, because we just want to test to make sure nothing went wrong. We're not really using the get joystick vector anyway. We just want to make sure that the project is running without all those extras that we removed. Okay, so we can leave that as is for now, because we have to return something eventually anyway. We'll just change it. So let's use the offset and the center here. Let's just print it at first, and let's see what it returns. Let's print our offset divided by the radius. Why? Because we're trying to get a vector, because when we divide the offset by the circle radius, it's going to give us a proportionate value for the vector, because it can never go beyond the radius of the circle. So you're going to get less than 1 every time. Basically, it's normalized. We can call the joystick vector in our GUI update, in our GUI input. So every time we move, we'd like to get the vector. Remember, this is only returning print statements right now. We're just testing to see what values are coming out of the print statement. Let's run this. So if I move to the right, as you can see, the x value is almost 1. If I move to the left, it's almost -1. If I move up, the y value is -1, and if I move down, it's almost 1. And that's exactly what we want, and anywhere in between gives you some sort of normalized vector. It does not pass a value of 1. So now we can return this value here, this offset, divided by the BG radius. Control C, Control V, and we can remove the print statement. Let's save this, and that's basically it. We just have to use this in some sort of movement now. So let me save this, and we can try to enact it in some way. And I want to be able to pull these files out into another project. So let me just create a folder, and let's call it virtual joystick. And let's just drag the image files in there, and let's just drag the virtual joystick files in there. And it's still going to work the same way. If you run, you'll see it's still connected the same way. Let's save this, and let's just create a test scene. So let's go back to the 2D scene here, and let's create a new empty scene. Let's call it a move test maybe. We'll make this our main scene soon, and let's just add our icon here. So we'll be moving our icon around. Control save. And what we want to do is we want to import our virtual joystick. So let's click the link and add the virtual joystick so it comes up here. You'll notice at the top here we can drag it down to where we like. Let's not put it directly at the bottom. We'll leave some space so that the stick itself doesn't go off screen. Let's make sure this is working. Great. So now we just have to wire it up. In the move test, let's create a function, and in this function, it's really simple. We can use a process or physics process, just like in one of our video tutorials by moving with input. We're just going to use a variable speed maybe. Screen is very small this time, so let's put a small value for speed. Let's say about 10 maybe. And let's use our physics process maybe. We're not going to use delta, so let's underscore it. And let's create a function called move by joystick maybe. You can call it whatever you like. And let's actually create the function now. And this is going to be pretty simple. Let's just create something called direction. It doesn't matter what you call it. We're just going to use it to plug in here. And the direction will be our virtual joystick. Let's drag this across here. Dot. Remember, we created a function called get joystick vector, and there it is. That's all. We get the direction, and let's plug that in to our sprite 2D here. Change the position of our sprite 2D to reflect our direction, and let's just add a little speed. Let's run this, and now if we move our joystick, we can see our sprite moving. I just want to test and see why the icon is still moving when we stop. So let's just print. Let me print the direction. I want to see if the direction is resetting to 0 when we release, and if it's not, you can figure out what's going on with it. So it says 0 now. Let's move away. It's not resetting when we release. Let's go back to the other code and see why that's happening. When we release, where do we release? Okay, if event is released, reset stick, and in reset stick we are just resetting the stick position. But remember, the offset is different from the stick position. The stick position is a result of whatever values we have when we move the stick internally. So right here, the offset is staying wherever we left it last. Let's reset the offset as well. So let's say offset is equal to vector 200. Great. So when we release, we reset the offset to 0 and reset the stick as well. Let's see if this works now. So let's move it around. When we release, the stick goes back to the center and the offset goes back to 0. So perfect. Let's close this off and save. I would have liked to show how to carry across these files into our other projects, the ones with the blend space 1D and the blend space 2D. Let me see if I have enough time. I'll do that. Other than that, I hope this was informative, and see you in the next one.